Guten Tag. Hello, everyone. How are you doing on DroidCon? Thanks. Oh, I didn't know it would be so loud here. OK, so my name is Piotr Prus, and I'm working at Tilt, which is a new e-commerce app where you can buy things during video stream. And I will share today with you my learnings from sending a lot of emojis on the screen and show them to other users. So what I will be doing here on the stage is building this emoji cannon. So every time user tap on the button, we are sending one of the emojis with random rotation and different emoji code. And it fade in and fade out after a few seconds. So let's try to build that and talk about some challenges. So first, we'll need the starting point and end point for this animation. And I will make it really easy for that example. So I'm here taking just as a starting point half of my screen and something around 90% of the height, which will start somewhere there, so it works. And then for the endpoint, I will randomize it from 0 to full width and also taking around 20% of the height of the screen. So every emoji is ending its animation somewhere in this rectangle. Then we'll randomize the rotations from minus 90 degrees to 90 degrees and build the fade out. So for every animation that I have here, they are all simple animation, just an offset alpha stuff. I have used the anima tables, so I'm running those animate too. And since everything here is in coroutine, I can await all of them. And after that, I'm just calling my opacity to run to 0, so it nicely fade out during 2 seconds. So to have everything in one place, I'm putting everything in a box. And in this box, I have an offset, rotate, and alpha modifiers. And we have this text with the unit code, and we have our emoji displayed. So to add that really on the screen, I created this data class, my emoji, that holds every parameter that I need to display this beautiful animation. And then whenever user tap on fire, I'm adding this to my mutable state list, which is remembered in my parent composable. And then for each of this emoji, I'm calling my other composable function with single emoji container, and this is the whole screen container which contains this animation. So as you can see, everything looks good. I could stop talking now. This just works. Everything's fine. But what could go wrong? So let's go to Layout Inspector and see our recomposition count, how it looks now. So when I fire one emoji, you can see here that our recomposition count goes really crazy. We have more than 250 recompositions. How it's possible? It just floats on the screen for 2 seconds. Well, we need to manage these recompositions. And single type events were always tricky in Android. And nowadays with Jetpack Compose, when we need to display, so react on every state change, it's more tricky than ever, in my opinion. But hopefully there is a nice article, Jetpack Compose Debugging Recomposition by Ben. And one of the key quotes from this article is, prefer lambda modifiers when using frequently changing state. So modifiers are effectively immutable objects, and when translation change or alpha or whatever, this modifier tree is removed, and we got the new recomposition tree instead. So whenever we have the new modifier, everything is recomposed. So our compose is called every time our offset change, alpha change, or rotation. So to fix that, we need to change our modifiers to their lambda versions. And hopefully, for offset, we have one. So just do not call the offset standard modifier, but it's lambda version. So now everything is in lambda. We can use this int offset and put our animatables offset in it. For rotation and alpha, we do not have the lambda versions. So what we can do here instead is putting the graphic layer lambda. And graphic layer can be used for a number of parameters that are changing your composable. So everything that can graphically change in the composable, you can call from graphic layer. So we have rotation Z, rotation X, Y, and also translations, and we also have alpha. So now when everything is in their lambda versions, we can double check our recomposition count. And as you can see, every time I click on fire, the emoji comes into the screen, and we do not have those crazy recompositions. We just have none. So it is rendered once, and then just flow on the screen. Everything looks nice. But now let's try to fire 10,000 emojis. What could happen? Like, everything works now, right? So not quite, because we are skipping a lot of frames. We have this weird delay. Hooray. If you have a lot of this, that means that something is going on your main thread, and probably you should fix it. We also have an information that the main thread and our garbage collectors is trying to free a lot of memory. And in my case, after firing 10,000 emojis, I got 12 seconds freeze. So that's a lot. And when you will look at our memory footage from our Android profiler, we are going from 100 megabytes somewhere to 230, and it stays. So something is wrong. It should reduce, right? The memory should be freed. Why it's not happening? So our animation starts here, something around 100 megabytes, and ends there. But as I said, the memory is not freed. So we have a lot of these invisible items here. So when alpha goes down, the item really stays in our composable. It is still there, silently, not showing. The visibility is 0, but it's still there. So what we should do is just remove items from the list, and that should be fairly easy. So in my composable single emoji container, after all those animations and animate out, I'm calling my function on animation finished. And in this single emoji container, I have this high order function when I can just call my list and remove one of the emojis. So what do we have now? I'm firing something around 20 emojis. They're animating out, and something really weird happens. Emojis are like dancing and changing all over. What is going on? Any guess? So every time we are removing something from the list, our list changes, and it's recomposing again. So everything is dancing on the screen and changing. So this is cool, right? Our user will love it. So now we need to inform the view to do not recompose children when list is modified. And for that, we can use this beautiful utility function called key. So the key is this utility composable that is using a group or key block to execution inside of the composition. And this is how it looks. So it just takes some unique ID and then your block of composable. So now every time something changes in your composable but your key stays the same, it will not be recomposed. So in my data class, I'm adding this ID string to know exactly what emoji is on the screen. Every emoji now will have unique UID. So every time user click on fire, I'm adding this emoji with unique UID using just a random UID. And I'm wrapping my single emoji container with the key utility function with my unique ID from my data class. And now when we look on the layouts inspector, you can see that I'm firing something around 10 emojis, and after animation ends, they are removed from the screen, and this is how we like. It do not dance on the screen. It do not recompose the whole list all the time, so it's not making this weird effect. Everything looks nicely, and look at our memory. It goes down. So after animation ends, everything looks normal, and we are back where we were at the beginning. Everything looks good. Now we would like to updating it from view model, so some production example from Tilt. So when users are watching a streaming video in the app, they can react on this video, sending an emoji, and all other users that are currently watching the stream, they can see this emoji coming from left or right of the screen with some alpha to do not distract, but also inform that there are some reactions to that video. So how it works? We are sending one emoji from user phone. It goes to the backend, and at this moment, this is just our user emoji. And then from backend, it comes to our phone as a viewer emoji, and we display it, for example, on the left side of the screen. But then there is other user, and they can also fire some emoji exactly in the same moment. So we have another user emoji that will convert to the viewer emoji of another user, and so on. And for now, it's not that hard, but we can have thousands of users that will send thousands of emoji. That's why I made this whole example with emoji canon and try to figure out how those recomposition works. So in the view model, we'll have just the state flow with our set. So everything will keep unique. And backend is giving us just the two values that we really care about. And those two values that we have here is emoji Unicode and the unique UID. And then whenever we need to update the list, we are calling this from the composable and update the list in the view model. So we are removing it from the state. So whenever emoji is on the screen, we have this state in the view model is a set, so everything is kept unique. And all the other factors like rotation and alpha and things like that, we are keeping in composable. View model do not care about how we are displaying those things. It just matters if we should display it or not. So in composable, we are doing the same thing as in emoji canon. So we have the viewer's reaction and for each. And then we have this wrapper key utility function where all the emojis flies uniquely on the screen and they are not recomposable when something changes. So this is how it looks in the app. As you can see from the left and right side of the screen, we have some emojis floating in, and we can open now the reaction bottom bar and send our reactions to other users. So you have here almost exact the same approach as this emoji canon, and from the left and right side, there are different composable that flows in, and this is how it works on production. So key takeaways from this talk. Use Lambda version of modifiers when a lot of parameters change to your composable, but composable itself do not change. So use the key utility function if you do not want to have a lot of weird recompositions. Always check your number of recompositions. So when we are doing something in composable, we really do not pay a lot of attention to our recomposition count because everything looks good, right? But then when you have thousands of users and different changes to the screen, you will be surprised how many times these recompositions go nuts. And remember to remove the object from your state if this is not longer visible. So I'm not saying about this one visibility or one big object on your screen, but when you have a lot of objects and you are just decreasing the alpha, remember to remove it because it sits there silently and killing your memory. And bonus to this topic, I'm currently using this exact approach to build particle emitter. I might be open sourcing it later this year. And here you have some cool examples of how you can use that without any freeze. I went up to 100,000 simple composables, like a circle or something, and it works. Do not freeze your screen. So I'm not using canvas here. Everything is composable. So as you can see, I added blur here and there and changing the color during the animation and play a little bit with some gravity effects and things. So it doesn't freeze and looks cool. And if you would like to see how I'm working on that, you can follow me on Twitter. I will post when the library will be in Alpha 0 or whatever. And that's all. Thank you so much for listening.